welcome to another video from How the Universe Works. Now, yesterday was Isaac Newton's birthday. So happy birthday, Isaac Newton. And it was Jesus' birthday as well, wasn't it? Yeah. Yeah, happy Christmas. It wasn't actually Jesus' birthday, because probably not. It was a random day. But this is official like the Queen. He has an official birthday. It's not actually his birthday. Anyway, happy Christmas. Now, because yesterday was Isaac Newton's birthday, I thought I'd start with some stuff about Newton and his laws of motion, which sort of laid the foundations for all of modern physics. He had 3 of them. First one, any body remains in a state of rest or uniform motion unless a resultant force acts upon it. Put simply, nothing happens unless you make it happen. So I get this Toblerone. Right, I'm holding it here. It's not doing anything, and I can be pretty sure, assuming Newton was right, it's not going to just jump out of my hand and fly up out of the window, because the forces on it are balanced. If, however, I throw it upwards, I make a force upwards, it accelerates upwards, and then it accelerates upwards whilst it's in my hand. As soon as the force stops from my hand, it's only got gravity on it, so it accelerates down. Right, simple enough. Second law, which really includes the first law, you should have only had 2 laws. Should have definitely still called them second and third, that would be really funny. Second law says that its acceleration is proportional to the resultant force acting on it. And force equals F equals ma, so force equals mass times acceleration. Fair enough. And then the third law, that's every action has an equal and opposite reaction. So the Toblerone on the floor, I'll pick it up and it's not on the floor, but that's pushing down on me because it's got weight and gravity is acting on it. Therefore, I must be pushing up on the Toblerone with an equal force to the force that the Toblerone is pushing down on me. So the Toblerone is exerting a contact force on my hand. My hand is exerting an equal contact force back up on the Toblerone. And also you've got the Earth. Its gravity is acting on the Toblerone. The Toblerone is pulling the Earth up very slightly. But actually with the same force that the Earth is pulling the Toblerone down, you don't notice because the Toblerone's tiny. You should, it would be really funny if you did. You just get a Toblerone and move it around and pull planets around. It'd be brilliant. You just get a black hole instead of a Toblerone. So you could all die, but right, so another thing, right? I've 12 days of Christmas. Now, there are a load of formulae going around. There's the question of how many gifts you get in total over the whole 12 days. I'm not sure how many there is. I don't think there's a formula for it. But total gifts on a single day, that is essentially the sum of an arithmetic progression, because you got 1 gift on the first day, 2 gifts on the second day, 3 on the third day. It goes up by a common interval. So the number of gifts on a total day, that's the sum of an arithmetic progression, given by the formula Sn equals half n square brackets 2a plus brackets n minus 1 brackets d square brackets. So Sn is the sum of the series, or the number of gifts you get on a total day, or the total number of gifts you get on a day. Half, right, n is the number of days in you are. A is the number you start on. And then D is the difference, is the common difference each time. So the Yeah. So S is Sn equals half n, because n equals 1, because you start on 1. And then D also equals 1, because you go partridge in a pear tree, 2 turtle doves and a partridge in a pear tree. So you go 1, 2, 3, 4. So that will simplify to half n, 2 plus n minus 1. Which in turn, which multiply out, which can simplify to half n 1 plus n, multiplies out to get half n squared plus, on the nth day of Christmas, my true love sent to me a total of half n squared plus half n gifts. So the first day you get half times 1 squared is half times half plus a half, that's 1 gift, yeah? A partridge in a pear tree. Second day, you get 3 gifts, it works out 2 turtle doves and a partridge in a pear tree. That's half times 4, that's 2, plus half times 2, that's 3. Yup. Third day, 6 should be. Half times 9, 4.5, plus 1.5 is 6. Yeah, it does work. Another question I've wondered about with the 12 days of Christmas. Which thing do you get the most of? Because, right, first day you only get a partridge in a pear tree. Second day you get 2 turtle doves and a partridge in a pear tree. You're going to get 12 partridges. You get 12 drummers drumming. So how many turtle doves do you get? So every day for 12 days, you get a single partridge. Doves, every day for 11 days, you get 2 doves. Hens, you got every day for 10 days, you get 3 hens. So you can work it out as where n is the number of days along the gift is, and x is the total number of that gift. You end up with x equals 13n minus n squared, because you started with x equals you only end up with x equals 13n minus n squared. Now, the gift you get the most of, you can work this out if you differentiate it. Now, because this would describe a curve, right? And you want to find the gradient at a point on the curve. So you'd say dn by dx equals 13 minus 2n, right? Differentiated that. Now, when a curve turns over, it's not actually, at the point it turns over, it's not, the gradient is 0 because it's flat, right? And that is the maximum point on the curve. So that is the gift that you get the most of here, because that's where the curve has the highest x value. So you get, and so the gradient of the curve equals 0. So 13 minus 2n equals 0. Therefore, 2n equals 13
Therefore, n equals 6.5.
So, gifts you get the most of are 6 geese are laying and 7 maids are milking. And you get how many of them you get, because you can put it back into that one. And you end up with 42 of each. You get quite a lot. You get 42 maids are milking and 42 geese are laying. You can work it out for the other ones if you like. Now, another thing, right?